and welcome to JAX 2016. We are here with one of our speakers, Mr. Lagergren. Thank you for coming here. And I have a question. Please tell me why is it bad to put QA people in a corner and not allow them to mingle with other departments?
Yeah, okay. Well, thank you for being here. I did a session about this, and the problem, I think, in software development is that development and QA have so different rules, which is like a perceived fallacy, because they should really be working on the same thing and be on the same team, preferably. I don't want to see a large difference between a QA engineer and a dev engineer, because if you have QA, which is like very common in the industry, on a different floor, on a different continent, even on a different team, a different room, they can't know the code that they are supposed to test as well, and they end up doing a lot of black box testing and like not knowing enough to do proper QA. So in any team I run, I try to have very little difference between QA people and dev people. There is no difference in value either. It's like an American thing to sort of treat QA as second-class citizens, which is in my opinion, completely wrong. Only when QA and dev work together can you get proper testing and knowledge of the code base to do the proper testing.
Of course. And in your session you said that warnings are errors. What do you mean by that, and what are the tricks and tips to avoid falling into that trap?
Well, warnings are errors. That's you have to be really careful when you build software, because you have a large software project and you don't follow the code standard properly, and you don't run things like lint on it and like the most pedantic compiler flags you can find. You will miss warnings, which is even worse. But if you have warnings and ignore them, they might come back and bite you. So anything that is a warning on one platform might well be an error on a different platform. So I would argue that for good software quality, you should always treat warnings as errors and terminate the build if you have a warning. And you should run as pedantic, I might even say as fascist compiler flags as possible to prevent this from happening.
Thank you. And you also mentioned the term terror testing.
Yes, terror testing.
Could you explain?
Yes, I can explain. When you can't do enough, like there are some bugs that you can't find just by black box testing or white box testing, or you might not have the core files or crash dumps to do IT forensics. Something might happen in production after 24 hours and you don't know where it comes from. So you need to harden software against this kind of untestable bugs, and you do that by running a corpus of large applications for a long time before release, probably inflicting the software, if you use it yourself, on the development org to dog food it, and any bug that might crop up during this phase is that only happens once. If you can find it and do forensics on it, you get stable software. And terror testing, that means basically running more stuff along with this process, typically provoking things or tickling the areas of software where usually bugs appear, such as synchronization. You can run a lot of synchronization stuff in the background. If you're testing a JVM, you can try to run allocation threads that just allocate objects of different sizes and different types in the background to try to provoke errors from happening in the garbage collector and things like that. So that's what I call terror testing. Throw the kitchen sink at it, run for 2 weeks, and add all kinds of harnesses that run different things in the background that the app normally doesn't do to shake out bugs.
I see. And I was wondering, since you have like 2 decades of experience in the JVM scene, I'm sure you had your battle scars.
Yes.
So maybe you could just give us an example.
Well, battle scars come from improper testing again. Like not building the proper test infrastructure from the beginning was a mistake that we made. And also when we inherited Sun Microsystems, when I worked for Oracle, we needed to retrofit a lot of QA infrastructure there to make sure that we could actually do large changes in the JVM, to make sure we could build the OpenJDK in the same time, to make sure that we could get bit perfect builds, that are bit identical builds on 2 machines, and a lot of stuff like that wasn't in place. So that was quite a battle. And in the OpenJDK, they've done tremendous work in the build and infrastructure teams, but they aren't there yet. So that was like one of the worst battles, I think, making sure that we got proper performance and QA infrastructure and build infrastructure in place for the OpenJDK when we started messing with it in 2010 in the Oracle corporate world.
Okay. Is there anything I haven't asked you about and you would maybe like to share?
I'm not sure. My session today was on proper testing practices and QA practices. I mean, performance is important. That might be a topic to make sure that to have regression tests and try to stay in a baseline. Performance engineering is a whole discipline of its own, but it ties into build infrastructure and testing infrastructure very well. So I'm currently working in performance engineering, so I wanted to mention that.
Perfect. Thank you very much for coming.
Thank you. It's a pleasure.